Okay, so we're going to learn how to estimate the sample mean and sample standard deviation when your data has already been summarized into, say, a frequency table or a histogram. These are the two formulas we need to use. So to calculate or estimate the sample mean, we are going to calculate the sum of x times f over n. To calculate or estimate the sample standard deviation, we take the square root of the fraction where the numerator is equal to the sum of the quantity x minus the sample mean squared times the frequency, or f, all over n minus 1. So once again, where x is the midpoint of a class, f is the number of entries in that class, n is the total number of entries in the distribution, and n can be found by summing the frequency. Let's see an example. We're asked to estimate the standard deviation of the AIRAC customer frequency table and round our answers to 1 decimal place. Here we're given the frequency table and also given the histogram of this particular situation. We have 5 classes. Each class gives the corresponding frequency. And so we have some work to do here to calculate some midpoints and some sums. So let's get at it. Okay, I have the data or the frequency table inputted. If you weren't given the frequency table and only histogram, you're going to have to figure out those midpoints and the lower boundary, upper boundaries. In this case, we're given lower class limits and upper class limits, so we can find those midpoints pretty straightforward or easily by taking the sum of the lower class limit for the first class and adding the upper class limit and then dividing by 2. Okay, so that's just the average of the lower class and upper class limit, known as a mean, even a midpoint, right, of the class limit. Okay, so we get 2. I have to do 4 more calculations, but I'm going to take advantage of Excel's dragging feature, putting the cursor in the lower right hand corner, clicking it, and dragging down without letting go once I click. Okay, so the formula for estimating the sample mean is the sum of x times f all over n. So we have to find some sums because n is also a sum. All right, before we could figure out the sample mean, we need to add the x times f's. I'm going to put that under column E here, and I'm going to click on my first midpoint, which is 2, times the corresponding frequency of 3. I'm going to get a value of 6 here. Let's go ahead and drag that down to automate those calculations for the rest of the classes. Okay, so let's go ahead and figure out n, which is just the sum of my frequencies. These are these numbers in this column here. So we get 40. We also have to figure out the sum of x times f. So that's the sum of these numbers here. Okay, so now we're ready to find the estimate for the sample mean, known as x bar. Okay. So what does that equal? Well, it equals the 275 divided by the 40. So that's my estimate of the sample mean for this problem. All right, to estimate the standard deviation, we need to find the sum of the quantity x minus x bar raised to the second power times f. I'm going to do those calculations under f. So I'm going to open up a parenthesis, click on my first x value, which is the midpoint, which is not that number there, but 2, minus my sample mean of 6.875. Now, since I'm going to automate this, I want to tell Excel not to move from E12 because that's the sample mean. It's going to stay 6.875. So if I drag it without putting the $ in front of the E and before the 12, it will increment, and I don't want that behavior. Another way of doing that is just literally typing out 6.875. All right, so there's the quantity squared. Now I need to multiply by the corresponding frequency, which is 3. And now I got this quantity to be 71.29, such and such. All right, now I've got to do the other 4 calculations by dragging it down. Okay, and I just want to quickly show you the reason we did that is so that E12, the dollar sign stuff, so E12 does not increment, whereas the D2, D3, D4, D5, D6 increment because X was changing from class to class. The midpoint changed. Okay, so now we are going to estimate the sample variance, which is S squared. So we could break this down into, say, 2 steps or 3, right? Which is basically the fraction under the square root. So that's the number. Oh, before we could do that, actually, we have to go back up here and figure out the sum of this column because that's the sum of X minus X bar. So let's do that first. Let's jump in the gun. So sum of these guys here. All right, so that's the numerator. So then the variance, right, will be equal to that number we just computed, the 264, and then divide by my 40 here minus 1. Make sure you put parentheses around there, otherwise order of operations will give you a different value. So we're going to get a variance of 6.787, dot, dot, dot. But now I could finally figure out the estimate for the sample standard deviation. Okay, which is going to give me the square root of the inside of this fraction, and that's just the variance. So we're going to go ahead and calculate the square root of that, and there you go. Okay, so that's how you get the standard deviation. It's just the square root of the variance. You can do those calculations all at once. Now we were asked to round the standard deviation to 1 decimal point, so let's go ahead and do that. So we get 2.6. And that's how you estimate a sample mean and variance and standard deviation when you're given a frequency table or a histogram.